Hey guys, it's Miss Adams, and we're going to move on to section 5 of the Unit 5 test review, and we're really going to start focusing on our geometric sequences now. Just so you guys remember, for a geometric sequence, our explicit formula is a sub n is equal to a sub 1 times our common ratio of r to the n minus 1 power, and our recursive formula, we're going to list what our initial value is, and then we'll have a sub n is equal to this a sub n minus 1 term multiplied by the common ratio. So let's look at the first sequence. I've given you 7, 14, and 28. Let's go ahead and figure out what our common ratio is. And in order to do that, I can do 14 divided by 7, and that gives me a common ratio of 2. I can check that by doing 28 divided by 14, which is also 2. My initial value, so my a sub 1 is 7. So when I write my recursive formula, I can say that a sub 1 is equal to 7, and that my recursive formula is a sub n is equal to a sub n minus 1 multiplied by my common ratio of 2. My explicit formula then is going to be a sub n is equal to 7, which is my initial value, multiplied by 2 raised to the n minus 1 power. And in order to write this as an exponential function, I'm just going to have f of x is equal to 7 times 2, and I'm going to replace my n variable with x. So this is going to be to the x minus 1 power. Let's look at column B. Column B gave us our explicit formula, which gives us our initial term of 3, and our common ratio of 4. I'm going to go ahead and write the exponential function because it should model that exponential formula, or explicit formula, excuse me, except the only thing, instead of having a variable of n, I'm now going to have a variable of x. I know that my initial term for my recursive formula was 3, and so now I can write a sub n is equal to a sub n minus 1 times that common ratio of 4. Now on to the sequence. I'm going to start with the value of 3, but to get my next term, I need to multiply that by 4, so 3 times 4 is 12. I can also get another term in that sequence. 12 times 4 is going to give me the value of 48, and I could continue on with that sequence if need be. Now our column C, I'm going to start off with that recursive formula. It's giving me that my initial value is 5, and then now my common ratio is negative 2. So if I write this as an explicit formula, I've got a sub n is equal to 5 times negative 2 raised to the n minus 1 power, and my exponential function will be f of x equals 5 times negative 2 to the x minus 1 power. I know I'm going to start off with a value of 5. I can multiply that by negative 2 to get me negative 10. But if I multiply negative 10 by negative 2, that's going to give me the value of 20, because a negative times a negative is a positive. Then, problem 15 says determine if the sequence is geometric, arithmetic, or neither. And if it's geometric, we need to state the common ratio. When it's geometric, we know that we need to multiply. If it's arithmetic, we are going to add. So if I'm looking at my list A, I've got negative 6, negative 1, 4, 9. If I try to find a common ratio there, so I do negative 1 divided by negative 6, that gives me 1/6. Or if I do 4 divided by negative 1, that gives me a negative 4. Those don't equal each other, so I know that this is not a geometric sequence. Instead, I am adding the value 5 each time, so this is an arithmetic sequence. And it would have a common difference of 5. Let's look at B. So I've got negative 80, 40, negative 20, 10. So I can do 40 divided by negative 80. That gives me negative 1/2. And then I could do negative 20 divided by 40. That also gives me negative 1/2. So this is a geometric sequence with an r value of negative 1/2. The last one, I've got 6 divided by 2, that gives me 3. 18 divided by 6 also gives me 3, so this is geometric with a common ratio of 3. And we will move on to section 6 in the next video.